Hi, I'm Thomas Elbeck, and I'm going to demonstrate for you how you could use the Oliasoft WellDesign software to establish if and how you can kill a relatively challenging gas blowout. So if we go to the trajectory design module, we see that we have a deviated well. We have a casing program with a 9 and 5/8 inch production casing and 8.5 inch hole below. Reservoir module shows that we have a very prolific reservoir, 500 millidarcy permeability and 25 meters net pay. So we can expect a fairly high gas blowout rate. If we go to the blowout module and run a simulation, we see that, as expected, the blowout rate is fairly high. It's close to 20 million standard cubic meters a day. We're going to kill this through a relief well, a dynamic kill operation. So we've designed a relief well that intersects at the shoe. We are now ready to go to the kill module and perform the kill simulations. As we've seen before, we have the opportunity to run what we call a parallel kill simulation. So we've input base case mud weight of 1.6 SG and 11,000 liters per minute. And if we run this now, we see that we can come up with a matrix of results, which gives a range of combinations of mud weight and pumping rates that will kill the well. If we look at one of them, for instance, the 1.6 SG, 12,000 liters per minute, we see that we kill the well fairly quickly and we stay well below the frac pressure. So this is not the case if we go, for instance, to this combination, where we see that we are much closer to the frac gradient, and hence we choose to investigate further the 1.6 and 12,000 liters per minute case. Now, we know that we can kill the well with this, but the job is not done right yet. We need to establish if we could pump this rate through the relief well that we have designed. And when we look at the pump curve, we see that 12,000 liters will require a pumping pressure of 385 bars, which is well above what these pump liners can supply. So pumping 12,000 liters per minute will require pumping pressure less than 221 bar for this particular setup. Now, so this setup is actually 3 rig pumps pumping down the annulus. Assuming we have 4 rig pumps, we can also look at the case with all 4 rig pumps going down the annulus. Now, this is not an ideal setup, as we don't have any backup, and we would like to have 1 rig pump available for the drill pipe, either as a backup or as a means of measuring the pressure by pumping seawater at low rate. But we have the option of pumping kill mud also down the drill pipe, as I mentioned. So if we tick off this box here, we can go for a setup where we pump 9,200 liters per minute down the annulus and 2,800 down the drill pipe, which adds up to 12,000 liters per minute. And we could look at what this looks like. So we've done this up front as well. So the kill curve is exactly the same, seeing as it's the same amount of mud that exits at the bottom. If we now go down to the pump curves, we see that we are now within what the pumps can deliver, both down the annulus, 3 rig pumps down the annulus, and 1 down the drill pipe. So basically what we've done now is that we've shown that the combination 1.6 SG and 12,000 liters per minute will kill the well. It will stay below the frac gradient, and more importantly, we are able to deliver it with 4 rig pumps, each delivering 2,200 hydraulic horsepowers.